With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, a ball of radius 11 centimeter and mass 8 kg rolls down from rest down a ramp of length 2 meter. The ramp is inclined at 35 degree to the horizontal. When the ball reaches the bottom, its velocity is. So in this question, it is written that there is an inclined plane, and this inclined plane is of length 2 meter and with an angle theta. Theta is given here, that is 35 degree, and let us suppose its height is h. So a ball is rolled down from this point A and it reaches the point B with velocity is given. With velocity we have to find the velocity v. So we can write here that potential energy at A is converted into kinetic energy at B. Now the potential energy at A is mgh and the kinetic energy at B is sum of potential energy, that translational kinetic energy, and rotational kinetic energy. Now on further solving here, what we get, mgh is equals to mv square by 2 plus I for ball. Ball is a shape in the form of solid sphere, and for solid sphere it is 2 by 5 mr square into v square by r square. So cancelling r square with r square here, 2 with 2 here, what we get, mgh is equals to mv square by 2 plus mv square by 5. Now again solving here, mgh is equals to 7 by 10 mv square. Now putting the value here, cancelling m with m here, we get g is 9.8 and h can be written as 2 sine 35 degree is equal to 7 by 10 into v square. So on cross multiplying here, 9 by 9.8 into 2 into 0.57 into 10 upon 7 is equal to v square. So cancelling 7 with this here, we get 1.4. So 1.4 into 2 into 0.57 into 10 is equal to v square. So on solving here, we get v square equals to 15.96, approximately 16, which comes out to be v equals to 4 meter per second. That means the option third is correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.